Welcome to the first part of section 2, solving multi-step equations. What you will learn is how to solve multi-step equations and will determine success by solving multi-step equations in various forms and explaining the process of solving an equation. Let's review. The properties of equality allow us to modify an equation in order to isolate a variable. That means to get it on one side of the equation by itself so that you can determine its value or behavior. When you add or subtract in order to modify the equation, you do so to both sides to maintain equality and balance. And with multiplication and division, what you do to one side, you do to the other. And make sure that sometimes to check for distributing the factor of c to every term on both sides. Simplifying before you multiply. So let's solve and justify as we continue to review the equation n plus 3 equals 7. First step is to write our equation. And then, because we want to get the n by itself, we have an addition of 3 that we no longer have a need to have with the n. So we do its additive inverse of -3. What you do to one side, you do to the other to maintain equality, and simplifying for the answer of n equaling 4. We also saw our variable being multiplied by a value, like in this equation, 3z equals 12. Let's solve it by first writing it, and then multiplication is implied when there's no operator written and things are adjacent or next to one another. And now we will divide both sides by 3. That's the inverse operator of multiplication. And when we simplify 12 divided by 3, on the right we get 4, and when we divide 3 by itself on the left, we just get that one copy of z as we wanted, and that's our solution. Let's solve m divided by 5 is equal to -4. So notice that m is being divided by 5, so then that means after we write the equation, our first step to solving it will be to undo that division using its inverse operator of multiplication. And what we do to one side, we do to the other. What we do to one term, we do to the other with multiplication and division. And so on the left, 5 divides into 5 one time, so we just get one copy of that variable. We undid the division. And then on the right-hand side, the product of 5, a positive with 4 negative, gives us a -20. Remember that a positive times a negative is a negative because you are saying you have 5 copies of that -4 that you then add together. And whenever you have an odd number of negatives multiplied together, they net as a negative product. So here's our solution presented. So now we're going to move on, building on these prior skills, to solve multi-step equations that will have addition, subtraction, multiplication, division, at least 2 or more of those operators required in solving the equation. So remember, our learning intentions are to solve multi-step equations, and we'll know that we're succeeding when we're able to do that and then explain each step in solving that equation. So here are the steps for solving multi-step equations. It eventually becomes second nature, but the main thing is to realize you just work in the backwards way of going to your variable. In other words, you want to simplify away the parentheses first because they're a grouping symbol that if your variable is inside of it, then you can't get access to that variable to then get it by itself and solve. That's what solve means. So that's the first thing to check out. And you have one of two ways to simplify parentheses. Either distribute whatever is in front of the parentheses outside of it and multiply every term inside the parentheses and then deal with the results later. That can make the problem more complex and require more steps and more involved arithmetic. So sometimes it might be smarter with the mathematical vision of isolating that entire set of parentheses that contains your variable of interest. The reason why you would isolate the parentheses like you would your variable is because then you can divide whatever is being multiplied outside of those parentheses to the other side of the equation. And what that means is when you're solving for your variable that is now going to be released from those parentheses that are no longer needed, you don't have to undo what you just, if you had distributed. So that's why this second option is something important to look out for. And we'll return to that in part B of this series on section 1.2. And then once you don't have more parentheses, then you start looking for like terms on the same sides of the equations, and you combine them like we've been practicing in section 1.1, and you do the constants, you do the terms with, in this case, your linear term, which has the copy of your variable, typically x, to the first power. And then once everything is combined to get them to the other side so that constants go to the other side, all the x's go to the other side of that, and then you are doing that using inverse operations. And then finally, if there's a number multiplied in front of your variable, then that's when you're going to use the inverse operator multiplication and divide both sides by that value to isolate your variable, get a single copy of it. And if it's being divided by something, you do the inverse operator of division, which is multiplication. And then you do that to both sides to isolate your variable. So let's do a couple examples. So here we want to solve 3x minus 8 equals 4. So notice that we have two operators. We have multiplication with the 3 and the x, and then we also have a subtraction here with this negative 8. So we want to first begin solving by writing that equation down, and then we want to get this term that has our variable by itself. So then that means we need to blank this negative 8, and the way you do that is using its additive inverse pair to create a sum of 0, because when you add 0 to something, it doesn't change that something. Well, if we change on one side of the equation, we have to implement that change on the other side. And so now we have the sum of 4 and 8, or 12 on the right, and we have that 3x left on the left. So we want to undo that multiplication by 3 through division by 3 to both sides, into 12 4 times, and 3 into itself once, for the final solution of x equaling 4. Looking at another example, here we have more terms, but the idea is still the same, that we want to start by writing the equation and then start combining like terms. Here we have like terms between these terms with x's, and so we're going to do a combination with their coefficients. So we're saying we have negative 2 copies of x, and we're taking away 10 copies of x. And so then that's a negative 2 minus 10. Since they're both heading to the left in the same direction on the number line, we keep going farther in that direction on the number line. And so we start with, say, negative 10 hops to the left, and we're going to take 2 more hops to the left to arrive at negative 12x. And so I have a typo here, so let me fix that. So now we have the proper sum of negative 12x plus 12. And we want to get that term with x by itself. And so we have to undo this addition by 12. And that means we're going to subtract 12 from both sides. And 18 minus 12 is 6. And then on the right-hand side, we'll have that negative 12 left over. Now we have a negative 12x left over. So we want to divide by x's coefficient of negative 12 to both sides. And then we have the ratio of 6 divided by negative 12. And 6 is a common factor, which we divide out from the numerator and the denominator. So we get negative 1 half, remembering to assign the negative to the numerator for safekeeping of it. And so that is our final answer, that x is equal to negative 1 half. And now we'll wrap up the lesson and reminding ourselves that we started scratching the surface today of how to solve multi-step equations. And we know we're succeeding at this because we could describe the steps as we're solving and arrive successfully at an isolated variable to find out its value. Remember our properties of equality, that what you do to one side, you do to the other. That involves all four of the operators. And now it's your turn to go to Canvas to complete your formative assessment.